So good morning everyone. So this is B. Vijay Chandra, Assistant Professor, Department of EEE. I am going to explain the content regarding electromagnetic fields. Basic concept of field. What is a field? We know the field is the region surrounded in a place in which having every position is having some physical function. A concept of a charge which is having the field around it. If you have considered this is the region, in this region every point will have the physical function. This concept is called as field. If this field is produced due to electric charges, it is called as electric field. Charge produced due to electric charges. If the same concept of the field produced due to the magnetic effects, that concept of the field is called as magnetic field. In this concept of the field, what we have to analyze is how the electric charges will produce the field with respect to magnetic effects, and that is our concept, electromagnetic fields. So now we are going to analyze the this electromagnetic field in purpose of mathematical calculations. Now I have considered a charge Q1 and another charge Q2. I want to calculate the field between these charges. To calculate the field between any charges, we have to consider Coulomb's law. The Coulomb's law is stating that the force exerted between two charges is product of their charges, and the same force is inversely proportional to the square of the distance between them. Two charges separated by a distance r is nothing but calculation of the force according to Coulomb's law. What we have to do is, the first point, force is proportional to Q1 and Q2, that is the product of the charges, and the same force is inversely proportional to the square of the distance between the charges. And finally, the force is defined as Q1 Q2 by r square, where Q1 and Q2 are the values of the charges, r is the distance, and the charge units are nothing but coulombs. And the distance in the concept of meters. And this proportional will gives a proportional constant called K. In the space region, the value of the K proportional constant will represents the value of absolute permeability, and whose value is represented as K is 1 by 4 pi epsilon. Finally, the force is given as Q1 Q2 by 4 pi epsilon r square. By using the concept of Coulomb's law, we are able to derive the force between the charges. Now what my question is, we have to derive and calculate what electric field produced by charge 1. To calculate the electric field produced by charge 1, first we know how much force is applying it on charge 2. That is the calculation of the force. After this force, we can calculate the electric field produced by charge 1 by using the formula electric field is equal to force per charge. Just now we have calculated the force exerted by charge 1. if the force is calculated per charge, then we will getting the electric field due to the charge 1 on charge 2. So substituting the force expression in this electric field, we got E is equal to Q1 by 4 pi epsilon r square. Calculating the force on charge 2. And this is the concept of calculation of electric field between the charges. As we all know that the charges are located in the space. In the space, we are not having any dimensions. It is of n dimension picture. Due to the concept of n dimension picture, if we have observed a space of a charge having charges at any of the place, if this is not an single dimension or multi-dimension, in this we are considering a three-dimension quantity to analyze these calculations of electric field force. I am considering a three-dimension picture. These three dimensions are classified as one is Cartesian, the second one is cylindrical, and the third one is spherical. Analyzation of the quantities in the space can be done by the concept of this three dimension. This three dimension is classified into three categories. One is the Cartesian, second one is the cylindrical, and the third one is the spherical. Cartesian, cylindrical, and spherical. So now let's see the individual concept of this Cartesian, cylindrical, and spherical, how they have been used in the calculation of electric field between the charges. So the first concept is the Cartesian. So in this Cartesian, we just intimated that this is a three-dimension picture. So let's consider the three dimensions. Whenever there are three dimensions, the names of these dimensions nothing but the basic x, y, z. In this x, y, z coordinate system, normal scalar quantities cannot be considered in the space of coordinate system. It should consider the vector quantities. That is the concept of vector calculation in coordinate system. So the vector calculation, we can discriminate or we can differentiate that a vector and scalar is slightly different, as vector having magnitude and direction, scalar is having only magnitude. It is having magnitude and direction, and the scalar is having only magnitude. So just now we disseminated that scalar and vector, but now I want to calculate the field in Cartesian, which is of a vector quantity. So I have to consider the directions. How these directions can be obtained? Depending upon the axis of the coordinate systems, these directions will be determined. Let's see the determination of the coordinates in the Cartesian. Just now we intimated it is x, y, z. As the name itself indicates, I can take the directions as a bar x, a bar y, a bar z. So as we have already got the directions, placing the magnitude at the directions, we can determine the vector quantities of any charge located in the Cartesian coordinate system. There is a charge q located in the Cartesian coordinate system. I am giving the coordinates as x1, y1, z1. These are the position, a position of q in Cartesian coordinate system having the coordinates x, y, z. Now, if you want to calculate the vector quantity at this position, and I am naming this position as A, the vector representation should be like A bar, which is nothing but x, A bar x, plus y, A bar y, plus z, A bar z. Simply we have calculated the position vector of a charge in Cartesian coordinate system. So, this is the way of representation of a charge 1. Now, I am considering a charge 2, whose position is named as B. Similarly, we can have the coordinates x2, y2, z2, x1, y1, z1. Similarly, guys, how can we write the position vector at q? At position B, it can be written as B bar, as we have given the A as A bar, and the vector at position B will represent a bar on the top, B bar, which is having x2 A bar x. Directions will not ever change. Please make a note of that. These directions will never change. Only the coefficients will change. y2 A bar y, z2 A bar z. So now what we have understood that I identified a position A and position B in a field in the coordinate system of Cartesian and found those values in terms of vector. Now let's find the distance. Why? Because we just came back that to calculate the Coulomb's law between two charges, we should calculate the distance. So to calculate the distance between these two charges of having the positions x1, y1, z1 and x2, y2, z2, just calculate the distance. In a vector calculation, the distance can be represented as AB bar is nothing but B bar minus A bar. Simply we can say that x2 minus x1 A bar x plus y2 minus y1 A bar y, z2 minus z1. So what we have calculated is the distance. From this distance vector, we can calculate the magnitude of this vector, that is modulus similarly of x2 minus x1 whole square plus y2 minus y1 whole square is a concept of calculation of magnitude between two positions when these positions are located in Cartesian coordinate system of positions A and B. By using these calculations, now I am going to calculate the force between these two charges when Q1 is having 5 nanocoulombs, Q2 is having 6 nanocoulombs, with the positions A at 1, 2, 4 and position B 6, 9, 5. So let's see this example, how we could solve this with this data. So let me have the data once again. The charge value of Q1 is 5 nanocoulombs, charge value of Q2 6 nanocoulombs, position A 1, 2, 4, position B 6, 5, 9. So we just calculated the Coulomb's law force is nothing but Q1 Q2 by 4 pi epsilon r square. This is the scalar form of force. Just intimated that a scalar form can be converted into vector form simply placing the magnitude. If you have seen, observe the diagram of these charges, a charge Q, I want to find the force on Q2. So here this arrow indicates that the Q2 is having the force from Q1. So my force direction on Q2. So the vector representation of the force can be represented as Q1 Q2 by 4 pi epsilon r square. This distance is from charge 1 to charge 2, which is having a magnitude a bar r1 2. So this is the formula of force in vector form. This is the process in scalar. As the location is in the space which is having the coordinate system, it is modified into the vector form. So now the vector form of force is the expression. Simply substituting the values here. 5 nano, this is 5 into 10 power minus 9. 6 nano, 6 into 10 power minus 9. 4 into pi, and we are having the epsilon, whose value of epsilon is 8.854 into 10 power minus 12. See, now we have to calculate the distance. Just intimated in the previous slide, how the distance can be calculated between the two positions. So position 2 minus position 1 whole square plus square root under. Let's go for the position that. By using that formula, I am calculating the distance r12 square root of 6 minus 1 plus 5 minus 2 plus 9 minus 4. So we got 6 minus 1 5, that is 25. 5 minus 2 3, that is nothing but 9. 5 square 25 square root of 59. You got the distance. Here I acquired the square 59. Now what we required is the calculation of the direction. Up to now we have calculated the magnitude and force. Now what is the concept of this direction? We know that vector is equal to magnitude and direction. So now what is my direction? Simply vector by magnitude. Is it simple now? Now can you calculate the distance and direction of this? What is the direction of a bar r12 is nothing but we have to calculate the vector from 1 to 2, that is AB bar by modulus of AB bar, nothing but 6 minus 1, 5 A bar x plus 3 A bar y plus 5 A bar z by square root of 59. Just a simple concept that we have already calculated the coefficient difference. After calculating the coefficient difference, again there is no need of calculation. We can simply write the first one is 5, 3 and 5. We got the vector. So replacing the vector here and we have to do the calculation. So guys, I think it is a simple concept that calculation of force between two charges in Cartesian coordinate system by the concept of vectors. Thank you. That's all.